think we're about to be on here. Oh yeah, we're live.
Yeah.
Okay, very cool. Welcome everyone to our live stream. We're going to get started here in probably 2 or 3 minutes. What we're going to be doing today is Ask an Astronomer. So if you have any questions for our astronomers today, Cooper and Marcus, feel free to drop your questions in the comments below. What we're also going to be doing is answering questions that people have asked through Twitter or Facebook. And any question that you ask today will be added to this list of questions. We're going to try to hit as many as possible. But this is going to be a new event that we're doing here on our Facebook pages. This event is going to be, at least for right now, Mondays at 5 p.m. However, we might change this time a little bit. If we do, we'll be sure to at least announce that. And you can look for more announcements on our future shows, either on the Sky Theater Facebook page or on the RUAC page, the Rafus Urban Astronomy Center. We are doing Monday Ask an Astronomer events. That's probably going to be twice a month. And then we are doing Wednesday's trivia. That's still happening at 7 o'clock, Wednesday nights. And then Saturday afternoons at 2 p.m. we are doing our live Star Talk events. So we're going to get started here in just a few minutes. Besides that, I do want to say thank you very much to our donors. Thank you so much to everyone who has donated online. You can find our donation page either through Facebook. They're the pinned posts on our Facebook pages, or you can go to UNT Astronomy's website. Our astronomy page has a little campaign going where we are essentially trying to continue to raise funds so that we can maintain our facilities and continue to produce these kind of online live shows for you. So we have more show ideas and more video ideas we're hoping to be rolling out that might not be live but might be like pre-recorded videos that we'll put together that might be more educational in variety. Today we're going to be answering questions from a wide variety of topics. Basically general astronomy to how certain things like stars or the sun or planets might function. And they're going to be really spearheaded here by Cooper and Marcus. Cooper and Marcus are grad students who are PhD candidates, if I'm not mistaken, at the UNT in our physics department. I will essentially hand it off to Cooper and Marcus here. Whenever you're ready, take it away, and feel free to introduce yourselves.
Thanks, I'll take it. Cooper, go ahead.
Hi, I'm Cooper. My name is Cooper. No, I'm a graduate student at UNT. Currently I'm researching quasars, which, for lack of a better term, it's whenever there's a giant black hole at the center of a galaxy just eating all of the stuff around it. Yeah, it is. It's really interesting. I really do enjoy it, and I'm at the most part, I basically study what comes out of it, for lack of a better term. And then Marcus over here also does that, but also at another whole level. So if you want to chat for a sec.
Hi, I'm Marcus. I'm a grad student at UNT, and my name is Marcus. I also study quasars. Cooper has been mostly working in the infrared, correct?
Mm-hmm.
The infrared is a very low energy band of the electromagnetic spectrum, so it's right above radio waves. But I've been working mostly in the X-rays. The X-rays are very high energy, and I've been watching how quasar or black hole central engine systems evolve over time. I have 17 years worth of data, and I've been making plots of how the light changes over time, and I've been making basically a kind of a loose model of how very distant quasars evolve over time. I'm also working on a project in the infrared where I'm trying to take some quasars very far away, and I'm trying to remove the light that is emitted by the black hole so I can see the galaxy that's around it. Because what defines a quasar is a very bright black hole engine in the center that is so bright that it pretty much obscures the host galaxy around it. So I'm trying to remove that bright light so we can see the host galaxy and see what's going on at really far distances around the black hole. So that's what we do. You want to start answering questions?
Yeah, so we do have a good list of questions already, and then we're going to kind of get into you guys' questions as this goes on. Um, of
So
which,
as you're talking, feel free to say anything you want in the chat, and we'll talk about it.
yeah, we'll do our best. Yeah, I'll say that much. Uh, sure, we're not the most, I don't know everything in the world, but I know at least a good bit. I'll say that much.
I think there's about 2 or 3.
2 or 3 things about the world. So let's go into this first question here, and we have John Littlevoice says, what's the best analogy that you've ever seen to describe how big the observable universe is compared to little old Earth? Which I think is a fantastic question. Honestly, astronomy is one of those experiences that you get that really you start to understand our place in the universe. Earth is very, 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 very small in comparison to the entire universe that there is. I think one of my favorite analogies for that, honestly, is from it's the little pale blue dot.
Pale blue dot.
Yeah, the pale blue dot. Which, if you haven't seen, that's going to be from Voyager 1, actually, as it essentially was leaving our solar system, which was a probe that was launched a very long time ago. Carl Sagan actually requested that the Voyager 1 turn around, take a picture of Earth from its position leaving our solar system. And
I think it was around, I think it was in Saturn, or by Saturn when I took it.
Was it by Saturn? Okay. Forget that. Yeah. So it was by Saturn. I mean, here we go. But as it was leaving Saturn, it turned around and it took a picture of Earth in just what you were looking at. If you were living on Saturn and you were looking at Earth, this is what you'd see. And essentially, on the screen, all you're going to see is a pale blue dot, which is the whole reason behind that. And Carl Sagan really goes into depth on this early on, and it's a very interesting picture to look at because it kind of puts you in perspective of you're only at Saturn, yet Earth is reduced to the size of a pixel. So imagine what that will look like, a galaxy away, a universe away. I mean, the thing is, the universe is much, much larger than really anybody gives it credit for. So that's definitely what I would say. Do you have anything, Marcus?
Directly answer the question, I don't have an analogy I can use, but I can give you a little perspective. Think about whenever you look up at stars at night, you don't see any planets around them. And even with your naked eye, you cannot see one of the ways we detect exoplanets is we watch a star for a while and we see its light curve dip. And that means a planet is moving in front of it. We can't even see that with our eyes. And so think about if you were on a planet at another star, you wouldn't be able to see us, you wouldn't be able to see our transit, and we're one of the small ones. So we're very little.
Mm-hmm. No doubt. Generally speaking, we are very, very small in this cosmic arena that is the universe. So
I think that's cool.
I definitely think that's cool. Let's see. Okay, next question up. That was a very good question. What is the difference between nuclear fusion and nuclear fission? Okay. So we have a bit of things. Marcus, do you want to start on this one?
Okay, well, I'll go ahead. I'll start with saying, why is this an astronomy question? So nuclear fusion is basically what powers stars. The core of a star is hot enough that the atoms are just bouncing around in there because there's such high energy, and they collide. I'm sorry, not the atoms, but the protons in the very center of a smaller star. They collide, and they undergo fusion, and that fusion lets off gamma rays, which puts out radiative pressure, which pushes the material of the star out, and then the gravitational forces pull the material of the star back in. So stars stay in equilibrium by radiative pressure pushing out, gravitational forces pushing in, and that's an engine that just keeps going for billions of years from fusion in the center. So there's two main types of fusion in stars, which another week we're going to go way more in depth in this. We're going to theme these live streams every week, and we'll do one on stars. But basically, there's a proton-proton chain, and then there's a carbon-nitrogen-oxygen chain, which happens in much larger stars. But in smaller stars, proton-proton chains, it's just simple fusion, just protons colliding and fusing. But once you hit a certain level, you lose the efficiency of your fusion, and we have a diagram that'll show you that. Cooper, you can take it from there.
Good thing. Basically, as these particles run into each other, there's a different amount of energy that's associated with each particle, the bonding energy that is associated with them, whether it's keeping the neutrons to the protons, whether it's keeping the electrons in the particular orbit that they're in. And so as these, actually I need to pull up something here. As these molecules get larger and larger, and as we start seeing it get closer and closer, as we get to a point where you hit iron. And iron is a magical, beautiful element, only in the fact that iron is where fusion begins to stop. Iron, you will fuse basically hydrogen to helium, helium, so on and so forth, lithium, beryllium, all these great elements, all the way into iron. And then once you hit iron, it's no longer energetically plausible for you to continue fusing iron to iron. So, and we'll discuss this, I guess, a little bit more next week when we get to...
During our Star Week.
During Star Week. Basically, though, when you get to iron, stars are done. They're done fusing, and the end of their life cycle begins to start. So what happens after that point would usually generally be fission. And that's basically the breaking down of one molecule into multiple. It could be various processes, but nonetheless, it no longer is energetically favorable for iron to fuse to iron. So, yeah.
Yeah, so you hear a lot about nuclear reactors and nuclear energy, and you also hear about trying to achieve fusion on Earth. Once we are able to reproduce fusion on Earth, then we'll have unlimited free power. The problem is that we cannot produce systems energetic enough and hot enough to reproduce fusion. We need at least 1 million Kelvin to fuse hydrogens, and that's just we don't have an engine that can produce that kind of energy yet. But that's what powers stars. We are able to achieve some type of fission here. But it's very expensive, it's hard, but it's clean. We need nuclear power. So we can move on from that.
So we do have some questions here from chat. And so one of them coming from Tiara is, can you tell me more about the comet Neowise, and also, do quasars eat galaxies? So I'm much more advanced knowledge in the last part of that question.
Yeah, short answer on the comet, no, because I haven't heard of that.
Well, Neowise is a comet that's coming into sight very soon, but I will say, you would be surprised how much debris actually hits the Earth on a daily basis. There is a lot of stuff that actually comes down to Earth that just burns up in our atmosphere. And so what we really see on the ground is just the remnants of those things. And I actually think that our producer here, Cade, might be able to help us out a little bit in terms of Neowise specifically. If Cade wants to hop in here in a second.
Yeah, here we go. Hey, so Comet Neowise is a comet that we're going to be able to see here over the course of July. However, from North Texas, we're really only going to be able to see it either very early in the morning or kind of in the middle of the night, like 2:30, 3 a.m. So if you're in the Denton area, it's going to be a little bit difficult to see, but you will be able to see it. It's going to be in the northwest, and it's going to shift every day. It's going to go across Ursa Major every day. It will basically move, I think, a degree across the sky, but it's going to be more or less at the same height above the horizon every day. But you can Google it. In case you're not in Denton, you can look around and figure out where it will be based on your location. You can also use the program Stellarium to figure out, or another kind of like star finding maybe app on your phone or something like that, to figure out exactly where it is right now and where it's going to be either early in the morning or late at night. Sunrise right now is like around 5:45, so you won't be able to see it really too much after then. But if you get up really early or out late, you should be able to see it. And then if you're north of here, if you're north of Texas, it's going to be a lot easier to see, like around 10 or 10:30 p.m. It'll be really nice to see, and it's supposed to look amazing. So check it out and Google, I guess, what area you're in, and then you should be able to find like a calendar or something like that to help you exactly figure out when you can see it. Yeah, hope that helps.
Thank you, Cade. Yeah, for those of you that have iPhones or iPads, there's a really good app I use called Night Sky. It has a free version, and you can search up the comet. You can time travel, see where it's going to be at its exact time and date. Night Sky, really good app for this stuff. So for the second part of that question, do quasars eat galaxies? The thing is, a quasar is the central part of a galaxy. So whenever you see these really, Kate, I don't know if you can, but if you can find a picture of a galaxy merger and put it up. If not, it's okay.
Give me just a moment.
Okay, so quasars specifically refers to the active galactic nucleus, which is the center of the galaxy, where the black hole and a big cloud of dust around it is, and the accretion disk. And then around it's a host galaxy. So what we call a quasar very far away, up close, there are similar systems that we would just call galaxies, like the ones with the really pretty spiral arms. And yes, they do eat each other. They're called galaxy mergers. And we are, so a galaxy merger is whenever two galaxies are just floating through space and they collide. And fun fact, we are actually on a collision course to merge with the Andromeda galaxy.
Right. Right, and here's the thing is, while quasars are definitely at the center of galaxies, quasars, at least from what we can see, now granted the observable universe is only so large, but at least from what we can see, quasars do have some kind of evolutionary cycle that we are basically, that's what Marcus and myself are researching into, is we're trying to figure out how do these things develop as they get older? How are these galaxies interacting with these quasars at the center of themselves? Which is a growing science, and at the moment that's basically where we're at. But no, I think this is a great question. Do quasars eat galaxies? The answer is both yes and no. They don't completely devour the galaxy, but they definitely do eat. Right. They're hungry, so they have to eat something.
Something to add here. You could kind of say that a quasar does eat its host galaxy, because a quasar is composed of a black hole, and then around the black hole is what we call an accretion disk. And that's a thin disk of really hot material that's falling into the black hole. And over time, over billions and billions of years, some of the matter and dust and gas from the host galaxy can fall into that accretion disk. So over time, the black hole does slowly eat parts of it, but it probably won't ever eat the whole thing before the universe dies.
Sure.
The heat death of the universe.
We have another question from the live stream here. Graham Schmidt is saying, have you ever experienced any anomalies in your data that suggests we are not alone? Graham, I will tell you that in my personal data, I will say no. But that being said, I 1000% believe that we are not alone. I believe, what was the Drake equation, is it?
The Drake equation, yeah.
The Drake equation basically suggests that the likelihood of us being alone is very slim. It is
All of them. Those stars die, their gases disperse. I forgot, what was the first part of that question?
Briefly fusion and fission earlier, but anything that is currently fusing hydrogen into helium, that is what a star is technically classified as in the astronomical sense. But yeah, no, I definitely agree with everything that Marcus was throwing out there. With yes, a nebula essentially is the start of that, because a nebula is like essentially a collection of gas, but that gas eventually falls under itself in its own gravity, and it begins to fuse into helium, for lack of a better term. So next up, we have from James. James says, "Are the large and small Magellanic Clouds remnants of a past galaxy merger?" Now, personal answer, I would say no. And the only reason I would say that is because both of the large and small Magellanic Clouds do show signs of having some bar structure. When they have this bar structure, and I will say there's three types of galaxies really. There's the spiral galaxies. There are four. There are spiral galaxies, barred spiral galaxies, which I would put inside spiral galaxies. Thank you, Marcus. There are elliptical galaxies, and then there are irregular galaxies. Generally speaking, irregular galaxies had some kind of merger in the past. However, the Magellanic Clouds, while they are technically irregular small galaxies, they do also show some form of bar structure, which, heaven forbid, if a motorcycle's coming across, but a bar galaxy is not going to likely have been in a merger, only because when these mergers happen, there's so much mass interacting with one another that it's very unlikely that they contain their shape that they're in. Now, I don't know if Marcus has anything that he wants to say on top of this about the small and Magellanic Clouds.
No.
No, he says it's hard no. But
no, I stepped out and I really don't know.
Long story short is I would say I would lean to no, but then again, here's astronomy for you. The genuine true answer is nobody knows.
Question?
The question was that are the large and small Magellanic Clouds remnants of past galaxy mergers?
Oh no, I think that they are nebulae from dead stars. Because galaxy mergers typically don't leave big clouds like that. We would be able to see the nuclei from the galaxies through them. So we'd see like really bright spots in the middle, which would probably obscure the cloud parts of them.
Well, that was, regardless, it's a really good question. Mm-hmm. Thanks, James. And let's move on to the next one. We'll say, next question, when will we colonize Mars?
Thursday.
What's that?
Thursday.
Thursday. Okay, we're going to colonize Mars on Thursday, everybody. Fantastic news. True answer is it kind of depends on our definition of colonize. I think there have definitely been some great steps in the direction of getting a human being physically on Mars, but unfortunately, space travel is very expensive. It's also very unknown. I think that's a running theme in this first episode of Ask an Astronomer. Is there's just so much unknown with what's going on.
That's in astronomy. There's so much we don't know.
Right.
And when we have a week on cosmology and we talk about dark energy and dark matter, you will be floored how much we don't know.
That's the big thing. We are desperately just trying to figure out what is actually going on in our own universe, and even in our own solar system, it's tough to tell. You know, we obviously have a pretty good understanding of what's going on Earth. Granted, we don't know everything, but we have a pretty good understanding of what's going on here. But even the next closest planets, I mean, Venus is absolutely uninhabitable. We sent a probe down there. Down to Venus not too long ago, and the probe burned up very quickly.
Like as soon as it hit the ground.
Yeah, it was absolutely done, because the thing is, now Venus is a horrible, hostile environment. You do not want to go to Venus. If you have the opportunity to travel there, do not go, because the true answer is Venus is extremely toxic in its environment, and I mean that literally. Is its atmosphere is not not eligible to live in. Mars, on the other hand, which is kind of the spawn of The Martian and all of these other movies and stuff, we could make it work. It's going to take a lot more work, though. If I'm being completely honest, it's going to take some work. I do
To answer your question, you have to send a DM to Elon. He's the only one that knows.
There you go. Send a DM to Elon Musk, and then we'll deal with that on the far side. But no, that was a great question. Next question. What's up?
A quick note on that. We should propose this for. We should do a week of the accuracy of science in movies. For those of you that have seen The Martian, it starts out where he's trying to evacuate the planet because there's a really bad dust storm. That can't happen. The atmosphere on Mars is far too light for really bad windstorms to come. Okay, continue.
Fantastic. Thank you, Marcus. Yeah, so let's move on to the next question. The next question is, what happens when two or more stars collide?
Oh, you can start that one. I've started all the other questions.
I've started. Okay, fair enough. Well, I'll say, so when two or more stars collide, there's a various amount of things that can happen, but a lot of times what happens is when two binary stars are orbiting around each other, if they become too close to one another, the bigger star will actually begin eating the other star. And I use this term eating because gravity basically says, hey, look, the bigger star is going to start having a larger gravitational pull than the smaller star. And so as they orbit each other, the smaller star will start feeding its mass into the bigger star. And so this bigger star just then gains mass, gets bigger, which we'll talk about next week in our discussion about stars. But nonetheless, that star will start to get larger and larger and larger and produce larger and larger black holes. Now, the larger and larger the black hole is, I mean, that has a definite impact on the structure of our universe, because essentially what we try to do is understand exactly what we're seeing. And understanding the size of these black holes and exactly how did that happen. A lot of times binary stars, the smaller star will basically feed into the bigger star and make that giant black hole.
So I don't have the stream open, but is the picture of the merger up? Cooper, do you have it open?
I don't have it open, but I can pop it open real quick.
Okay. So a quick note on stars colliding. So typically we have to consider gravity in space-time when we think of collisions in space. So I'm sure you've seen the analogy before.
I know discussion about stars, but
I had an echo. You have to think about the image of where space-time is like a flat grid. And if you haven't heard of this, please look it up because it's really important to understanding astronomical phenomena. So space-time is like a grid, and wherever there is a star or a planet or a black hole, there's a dip in that grid. We call that a potential well or a gravitational well. So things won't collide unless they are on an exact collision course for one another. What will typically happen is they'll be either, right, they won't be heading for one another, but they'll be heading at kind of an angle to one another. And that's whenever stars become binary systems. They'll be at slightly different angles, and then they'll hit each other's potential wells, and they'll start orbiting one another. So think about in Walmart, there's a charity donation thing that's like a big vortex, and you put a coin in it, and it falls and spins and spins and spins down to the center. That's what potential wells are like. So typically stars won't just collide. They'll approach each other, and then they'll hit each other's potential well, and they'll start orbiting. And then, again, I'm not sure if that pictures that, but if it is, you are viewing that potential well spinning happening. The more massive star, which in that picture I believe is a white dwarf. White dwarfs, again, we'll talk about in the Star Week. They are dead stars that have collapsed, and they're super, super dense, so they have a ton of mass. They have much more mass than a typical yellow star like ours would. So the star with the more mass would have a much larger potential well, so the yellow star in that picture is falling into it, like a coin going down that vortex. And the same thing happens with stars and planets. Whenever a planet's orbiting a star, over thousands and thousands or millions of years, that planet's going to slowly fall closer and closer into that star. Earth is doing it, but the sun's going to die before we make it to the center. But the planets are falling closer and closer, and eventually you hit what's called the Roche limit. The Roche limit is whenever two gravitational bodies are so close that the one with the less mass starts breaking up and just disintegrates and falls into the other. And that's what you're seeing in that picture. And that's what happens when stars collide. Once they get close enough, the smaller mass one just kind of dissolves and funnels into the other. The end.
The end. Well, yeah, no, absolutely. It's a great question. And let's move on to the next one. So Emily says, what planets can you see from the night sky, and where are they? Smiley face.
They're over there.
That. But yes. Marcus?
So the original astronomers, again, we always go back to the ancient civilizations, the Greeks, the Aztecs, the Mayans, the Incans. We have their artifacts, and they made maps of the sky. They would notice that certain stars would change position in different time of years. Some stars would be in a different position. And it wasn't until thousands of years later that we realized that those weren't stars at all, they were planets. So to directly answer your question, with the naked eye, we can see up through Saturn. That means we can see, actually, I don't know if we can see Mercury. Can we see Mercury?
Sure.
Mark on that.
Actually, I don't know if we can. I think Venus for sure is easy to see. Mercury might be a little bit tougher just because it's into the sun.
Right. So the the planets that are interior of us, which are Venus and Mercury, they have very specific times we can see them, or far more specific than the others because they're on the interior. It's a whole thing. We'll talk about that when we do a planet week. But we can see Mars very clearly. We can see Saturn, and we can see Jupiter. Past that, we really need a telescope. Once we have a telescope, we can pretty clearly see Neptune and Uranus. So with the naked eye, up to Saturn.
And actually, and point out, I believe it was Uranus that actually was discovered by an astronomer. So it was that the physics of our solar system suggested that there must be some kind of body that was the size of Neptune, and it was orbiting in this particular path. And it wasn't a well-known astronomer that figured that out, or that actually first discovered Neptune. It was just an amateur astronomer looking up with their own telescope looking and seeing, hey, the physics suggests that there should be a planet here. Let me look. And sure and behold, here they found it. And and what do you know? So I will tell you, amateur astronomy is nothing to scoff at, because amateur astronomy, I mean, that literally found one of our planets that we know of today. So if it is interesting to you, I highly encourage keeping looking at it, because here we go. I mean, that's one example of many, I'm sure.
And if planets and mysteries are interesting to you, you can look into Planet 9, which is a theoretical extra planet in our solar system, which again, some people, not all, some people think exist because of the physics and the position and the angles of our planets. This last year, some people have been saying it's debunked, but there are people out there that really believe we have another very large planet in our solar system. The problem is we just don't know where to look for it, because it would be so far away that it's too hard to pinpoint the exact angle we'd have to look at. But that'll be another topic for our Planet Week.
And thank you, Emily, for that question. Again, you guys can always ask questions rather through the Facebook live streams. We also have a Twitter page that you guys are more than welcome to ask questions through. This one comes from Morgan, and she asks, what are the best resources for an introduction to astronomy, stellar navigation, and stargazing?
You're here.
We're here. Right. Now, I will say, on top of that, Morgan, one of the best things that I think is useful, at least in terms of stargazing, is Stellarium, which is a free product that everybody can get to, whether you're on a Mac or if you're on a PC, whatever it is. Stellarium will actually let you see the night sky as it is most nights. Now, granted, we do have a much bigger issue nowadays with light pollution, and on top of light pollution, clouds. It turns out, if on the way, you just can't see into the sky, because you're just going to see the cloud, which is an unfortunate fact about astronomy, and that's why we've had so many more things that we send into space. We send much more of our telescopes into space, which the Hubble telescope. Say again, you kind of cut out there, Marcus.
There's another week for us. We can talk about telescopes and space telescopes.
Yeah, absolutely. And the James Webb Telescope is an up and coming telescope that we're going to be dealing with soon in the astronomy world, and that will be a big factor. But the true answer is, hey, if you look at Stellarium, that is a completely free program. It will tell you what the sky is supposed to look like that night. It will tell you what constellations are available, what stars are available, what planets are available for you to look at just from your backyard, essentially. And I will say it is extremely accurate. It's extremely great, because it's nice to be able to go out and know exactly what you're looking at.
And I don't know how old you are. Who was it? Morgan that asked that?
Correct.
I don't know how old you are, Morgan, but for anyone listening, if you're college age or late high school, take an AP astronomy course or take a freshman level astronomy course, because a lot of what I'm telling you today, I learned in freshman level introductory astronomy for non-science majors. So there is a lot you can learn without a ton of math or a ton of physics. Astronomy is a lot more accessible than you think. So if it's available to you, definitely take a course, because it'll expand your mind. With the little bit of math that's in it, you'll understand a real application of the math you learned in high school. With the physics in it, you'll get a real grasp and application of the physics you learned in high school. It's just a good thing to do to round you out, to apply the things you've learned before to something real and physical.
No doubt, no doubt. Let's see. Thank you, Morgan, for that question. Our next question is going to come from Robert from Facebook as well. He says, are you happy with the progress that SpaceX is making? Are you excited to board a ship to go live on another planet? I'll tell you, Robert, I'd be ecstatic to live on another planet at some point during my lifetime. I don't know if that's going to happen during my lifetime.
Robert's telling you it is.
Okay.
And so I'm excited for it.
Look, that's electric. I really mind living on another planet for just a hot minute to see how it's going. But no, absolutely. I am ecstatic with the progress that SpaceX is making, if not only just for the innovations that they make, but the genuine astronomical progress that they make. I will say astronomy is one of those sciences that some of their achievements are appreciated after the fact, because there's so many things that astronomers push the boundaries. They need the technology for this, and so they make the technology for this. So I will say I'm very excited that SpaceX is pushing those boundaries once again, because I feel like it did stagnate a little bit after we landed on the moon. But here we are, and if we get the opportunity in our lifetimes to go live on another planet, you'll see my name first on the list.
For those of you that don't know, and I'm paraphrasing here, I think SpaceX's mission statement or their slogan is because we think a future exploring the stars is far more interesting than one where we aren't. So I really like SpaceX. I love the progress they've made, especially with Crew Dragon last month, where they launched the first commercial company to launch people into space. That's an exciting step, because it's very slowly, but that it's becoming feasible and affordable for private companies to go to space. We'll expand technology. More and more corporations will be able to do more experiments, expand their technology. We are at a very exciting place. I do think that it's probably going to be the next generation that goes outside of our solar system, but I think we're on the cusp of that.
Absolutely. I think it's very exciting where we're at, because astronomy is really, it's just growing, and it's exciting to be part of that.
And Elon, if you're watching, hit me up.
If Elon's watching, okay.
I'll send you my ID. I want to.
Okay. Okay, we got another question. Thank you, Robert, for that one. Lisa from Facebook also says, "What is a day in the life of an astronomer like?" Well, Lisa, I will tell you my day in the life of an astronomer is like. Now, granted, I'm a graduate student. I am working with one of the astronomers that we have here at UNT. And most of my stuff is a lot of computer science, as we are observational astronomers. So basically what we do is we take in the data from the quasars, is what we have, or that we particularly study, but it could be stars, it could have been supernovae, it could have been whatever it is. A typical observational astronomist will basically take a, do you have a comment?
Astronomer.
Astronomer. Sure. A typical observational astronomer will take in data that they get from telescopes, whether it be spectroscopy or photometry. Both of those things just have to deal with how you study light that comes from these objects. And a lot of it turns out to be computer science, because we have to deal with nowadays large amount of data, and we really have to study these things in depth, just in a way to get a better understanding of where we are in the universe, what is going on in the universe. So most of my time is spent on the computer. It is spent staring at a screen that is also downloading and interpreting data. And Marcus, I don't know if you have any other suggestions on that.
Oh, yeah, it's a lot of computer science, a lot of our work is text-based computation, text-based computer using, because a lot of our software is text-based, because it's either old or there's just not the funding to make it more intuitive. So in order to do what we do, we have to learn a lot of Unix, a lot of programming, if you're interested in this, get a Mac or a Linux. computer, because you're going to have to know how to use them. You're going to have to know how to use Unix. You're going to have to understand file structures. And I'm not saying that to intimidate you. It's just what it is. And you'll learn a lot of that in your coursework if you come into this field. So it's not intimidating. It shouldn't be intimidating. You learn as you go. It's a learning experience. But our days are spent looking at computer screens. They're spent being a little bit frustrated with the program sometimes. They're spent looking at numbers. They're spent understanding file structures. They're spent waiting for things to download. They're spent fighting installing our software suites. So all in all, our job is problem solving. And that's the same for all of physics. Any physicist, any astronomer will tell you what we do is we problem solve. Period. Whether it's a computer problem, whether it's a math problem, whether it's a physical problem, we just solve problems all day.
And I know, and that's a great question, Lisa. I really do think that Marcus kind of summed it up there, where us having basically just tying everything together is we just solve problems all day, is for lack of a better term. And I think we've got enough time for one more good question here, and we have one from Damon from Twitter, and he asks us, what is the bucket list for career achievements? What is the lifetime goal for an astronomer or a physicist, and how do they measure their success or their work? So that's a very in-depth question there, for sure. And to be honest with you, I think, Damon, I leave it to Einstein. He was one of those people that at the very beginning of all of this stuff, I think died wondering, hey, what is the unifying equation to life? And to be honest, there wasn't one, at least as we know now. But here we are trying to describe everything in the entire universe under some unifying equation. He basically died wanting to know, is there one beautiful equation that describes everything that we see, everything that we know? And I think a lot of astronomy, I think a lot of physicists as well, will tell you that somehow there needs to be some beautiful equation to nature, but the true answer is we don't know yet. And that's a lot of what we do. A lot of what our work, even in quasars, in these black holes at the center of galaxies, a lot of what we do is trying to tie everything together and say, look, they're all the same. They just evolve in a particular way. There's one particular equation that will tell you, look, as this quasar gets older, this, and that are going to happen. That's what we're studying. That's what we're trying to figure out as we speak.
Yeah, Einstein, trying to come up with that one equation, he came up with 8 equations to describe space-time, but couldn't solve them. And there are now multiple accepted solutions because no one knows what the real one is. And just to further illustrate that Einstein died wanting to prove the things that he deduced, gravitational waves, he predicted those, but they were not observed for 100 years. If he were alive today, he would have won the Nobel Prize for gravitational wave detection. But you can only win the Nobel Prize if you're still alive. So we measure, I can't say we because I haven't made any good enough contributions to say that I'm contributing to physics yet. But definitely bucket list is to put a small piece of that puzzle into that grand unified theory equation. Even if it's just the smallest piece, because there are thousands and thousands of physicists. And we all have one goal, just to put the puzzle together, to figure it out. And every person can be a little piece of that puzzle. And it's not discouraging to not make giant discoveries. That's not really our goal. Our goal is to just trudge forward, to build on the shoulders of giants before us. So I want to do one more question before we wrap up. We've got a few minutes left. This question comes from Alana. If you had the opportunity to travel outside of the galaxy, but you have no guarantee of returning home, would you do it, and why? Yes, I would. Because we know almost everything on Earth, but we don't know what's out there. And I would spend the rest of my life floating through space, just looking at all of creation, because it's so beautiful and so mysterious and so scary. I just want to absorb it all in my eyes.
And I will say, I 100% agree there. I think the universe is fascinating. And to be honest with you, there's a lot that we just don't know, but it is gorgeous. There's so much of what we're looking at that when you see it in a photo, on the internet, whatever it is, it just doesn't do it justice. And I want to be able to experience that for sure. There's so much out there.
Think about when you take a picture of a beach or a mountain and you think it's so beautiful, but when you look at your picture of it, it just doesn't look good. Think about all that we're not experiencing looking at our telescope pictures. It's the same idea.
Absolutely. It's the same exact idea, and I think I would absolutely be on board with that. It's absolutely fascinating. And I highly encourage if anybody gets the opportunity to have that in their lifetime, you take advantage, 100%.
All right, we need to wrap up our questions there. A couple closing notes. This was our first week. We kind of just answered a smorgasbord of questions because these were what were thrown at us. But in the future, we are going to, if we have enough questions, we're going to try to theme each week. And what is our current plan for next week? I don't remember.
Stars.
So next week's going to be our star week. And then after that, we're going to leave up to you, the viewers. So soon after this stream closes, we're going to have a poll up on this page. And we need you to vote what the following week will be. It's either going to be cosmology or quantum mechanics. Is that true? Am I right?
Correct.
Yeah. So vote on one of those, whatever you want to ask questions about or learn about, and we'll talk about it. Any closing notes, Cooper?
No, I appreciate everybody who came out today to come and talk with us. Listen, we'll be here every week. And
this was a lot of fun.
And if you guys have questions, hey, challenge us. Because look, I'm not here to say I'm we are the all-being oracles, but here we are, giving our best knowledge to you guys. So I appreciate it for sure.
Yeah, thank you guys very much. I really enjoyed this. This was a lot of fun. So bring more questions, challenge us, make us think, make us say we don't know, because then we have something to go learn.
Exactly.
All right, I guess we'll sign off now.